Thanks very much, Ailey. Yeah, as Ailey said, just throughout this presentation, feel free to jump in with questions at any time, because we are kind of giving a bit of a whistle-stop tour of the course we have. So if there's anything that's maybe not clear, just ask us. Almost all of you know us anyway, so you know we don't bite unless provoked. So thank you very much all for coming. So today we are just going to discuss the short course we made on version control. We've no doubt been spamming you with emails about it. Hopefully some of you have had a chance to look at the course so far, but we'll just provide an overview of some of the considerations we had with the course design and the general layout of the course. So I'll kind of speak for the first half of the course, then pass over to Vinny. Oops. There we go. So yeah, this course was developed here by myself, Vinny, Andrew, who I don't know if he's online or not, Dave, who hopefully some of you have met by now, and we had an undergraduate who's left now, Sam, who helped us at the beginning of the course as well. So the kind of goals we had behind the course was really just to kind of encourage and promote the use of version control throughout the school and hopefully beyond that. So in lots of different areas such as research and also to our students as well as a valuable tool in the workplace. So the kind of pedagogical aims, I'm just going to close this because it's cutting half of it out. So we tried to design the course in a way that it would suit quite a broad set of cohorts, which is maybe easier said than done, but we hope that we've kind of struck a happy medium. So we're aiming to kind of promote this course to our undergraduate and postgraduate students. So this is all our honour students, usually aiming kind of level 3 and 4, because kind of feel the experience of programming at that point is a bit higher. So maybe in level 1 and 2, it's a bit too soon. And our master students, including our on-campus and ODL students as well. Our postgraduate research students, so our PhD students or MRes students across the school, and our staff, so our R&T and LTS staff as well. So we're wanting to make the course as accessible and available to everyone as possible. Taking this into consideration, we assume next to no background knowledge of version control whatsoever. So you can come in completely blind and oblivious to it and hopefully take something away from it. We've also tried to keep the course as kind of language independent or platform independent as much as possible. So we don't cover examples using a particular programming language such as R, Python, or Overleaf. We've tried to keep it as generalizable using things such as text files or markdown files, which are really similar in structure to text, just to make it as accessible as possible, irrelevant of the kind of programming background, because all these techniques can be applied irrelevant of the language you're using. As I said, we're trying to kind of design it in a way that caters to people's different requirements. We know that the kind of depth that people may use version control for will vary. So we don't expect people to complete the entire course, because it does go quite far and into some quite complex kind of terminology or kind of complex aims. And we've kind of developed this user plan, which we have down the bottom here, kind of to help students select, or staff as well, the best options available for them. So the first 3 units are really focused for the kind of single project user. So this is someone just working by themselves and just want to keep a nice record of what they're doing and developing. Then our units 4 and 5 expand beyond this into group projects. So talking about more kind of collaborative things, you see the real benefit of version control when you get into here when you're working with others. And then our latter chapters are kind of covering more of those advanced projects, so a lot more complex coding tasks, say your kind of package development things at that point as well. We've tried to lay it out in that way. And of course, people can kind of jump in and out and come back when the situation requires as well. So the availability of the course, this is actually something I was speaking about this morning, funnily enough. It's come up again. So the course is on Moodle, and anyone can access this within the school. We've sent information about this just with the access code, and it's also available kind of throughout to anyone across the university. So you should hopefully have a code already. If not, let us know towards the end. We can give you the info, help you sign up. The notes we're using an accessible HTML version for these notes, which were developed by Dave. These are primarily used in a lot of our ODL teaching for our data analytics ODL program. And they include a lot of really nice accessibility features. this paper down here, which Ailey is lead author in, does talk a bit about this if you want a bit more information and some of the kind of accessibility designs with this. So we use this within the core of the course material. And the slides today you can find as well on GitHub, because it's the best place to put it if I'm going to talk to you about it. Might as well encourage you to go and visit it, and we'll send around a link to those slides later too. Oh. And one little thing before I get into depth of what GitHub is in the course. Hopefully after this you'll go on and have a look through some of the materials, but we would love your feedback on this as well. So we are collecting some information to just help us improve the design of the course. It's our first iteration of it. There naturally will be things that maybe don't work as smoothly as we anticipated, so we'd love to know that to try and help improve things, and general experience of how people have found this, and the general experience of kind of teaching a general course on version control and how well that works. So all that information is available on the Moodle page, and we'd really appreciate your feedback on that. So now actually into what is version control. What's GitHub? What's Git? So we'll start with what's Git. So Git was invented by this gentleman over here, so Linus Torvalds, and his main motivation was he used another version control system called BitKeeper, but they started charging him money. So to get around that, he just made up his own one. I wish I was that intelligent. And this is just kind of some nice background. So his first commit message really was, this is the initial revision of Git, the information manager from hell. I don't want you to be too alarmed by that, but it can be a bit problematic at times. And he does have an entertaining README. I won't read through the whole thing, but I will highlight this bottom one here, which has some swear words on it. So it's a bit expletive. So you will hear the phrases Git and GitHub, and it's important to distinguish the difference between the two. So Git is the version control system. That's the system in the background that's helping us manage when we're updating and changing files. And it can effectively track changes in these files or the code within them. You can run this completely offline. So you can just have it on your own device, use it to help you manage and track all your changes. But where's the fun in that? We tend to try and share these things online. So we commonly communicate with this through a hosting service. And one of the most popular hosting services by far is GitHub. So Git is the version control system. GitHub is the online platform for sharing and hosting this version control system. So Git is not the same as GitHub, but they do interact with one another. So in terms of installing Git, it's primarily been designed as a software developer's tool. So it is not the nicest thing to install at times, and can be a bit of a pain. So it can be a little bit hard to install for some of us. And the way Git traditionally works, it's a command line program. For those of you at Robin's talk a few weeks ago, he demonstrated a lot of things through Git, which is running the command line. Some people are petrified of the command line, and that's fine, because I used to be one of them. But there is a workaround for this. We don't actually have to communicate with the command line if we want to use version control efficiently. We can install a GUI, such as GitHub. So we can use something called GitHub Desktop to help us manage it. We never need to touch the command line, and we can just pretend it doesn't exist. So in this presentation, we're actually going to focus on using Git through GitHub Desktop, so using this GUI instead. The one thing to add with the course, though, some of you will love the command line, probably spent loads of time on it, and we don't want to discourage that, because some people who design this also like it too. So on the course, when working through it, you can either work through all the examples using command line commands, if that's what you prefer, or using GitHub Desktop. You'll see this little switcher tab within the notes here. So this part here, you just click on the one you want to use, and the notes will update accordingly. And that will give you the commands that you want to do to follow through with these things. So the choice is there. But today, Vinny and I will talk about using GitHub Desktop instead. So your first thing to do is actually sign up for a GitHub account. The good news is it's free, so you don't have to pay for it. And you can also download the desktop app, which we use a lot through the course as well for free. And these are pretty straightforward to use. So this course will focus on GitHub Desktop, but there are other GUIs that you can use, quite a lot of popular ones. Vinny uses SourceTree. There's also Bitbucket as well. which I've not used. I use GitHub Desktop, so I clearly won the argument when what to put in this course by the looks of it. So that's the kind of general setup and kind of getting started. But I guess one of the things to motivate this is, what's the point? Why do we have to care about this? And really the main reason we have version control is it provides an efficient system of helping us track changes. And if we need to, and we will touch on this towards the end, go back in time to something, but we're going to add a little health warning to that because it can be a bit dangerous. But it allows you to also develop temporary and multiple different versions of your code. So if you're working in kind of complex projects, like this example here, so you want to test a new function in your code, what version control can allow you to do is you can implement it, and then you can see how it works. But if you want to add that to the main body of your code, you choose when that happens. You choose when to integrate it, only once you know everything works. So you can keep it on the side, work along with everything else, and when you're satisfied, you can add that back in. And that's kind of merging and branching, which we'll talk about later as well. And also we can keep multiple versions of the same thing too. So if you're sharing a package you've designed, for example, you could have someone who's using it and someone else is kind of developing something new they want to add with it as well. And if that stops it working temporarily, just kind of leave them to it, and everyone else can kind of use the standard version as well. So there are quite a lot of benefits in that sense, especially when you get into more complex coding challenges. These benefits really come into play quite strongly. And this is the other thing too, and we'll talk a bit about why this is very important research. GitHub is one of the easiest ways, I would say, to share your code or any kind of packaging software, for example, that you've developed with other people. And you can do it whilst you're kind of mid-development. You can also do it once everything's done, nice and shiny. And then other people can use your code, and you can use other people's code, because we should all share our work with one another. It's kind of the heart of academia. And also another thing as well, if you claim you have a method and it can do X, Y, Z, it can go to the moon and back, it's brilliant, but you don't release the code, or the code is a complete mess, you can't claim it does all these things. It's not stable and it's not safe. And this gentleman here, if you're submitting a paper and you don't provide a link to your code, he will likely reject it. So just keep that in mind. And this is probably coming a lot more prominent in reviews. A lot more kind of papers and journals require you to share a lot of the code you're doing. But I hope for your sake you don't have Vinny reviewing it, because he'll go over it with a fine-tooth comb. Yeah, sure.
But both this presentation and the previous one are all about computer programming. The reason I came along is because I want to learn how to do both controlling later. Can I do that too?
No, you can. We'll go through examples. Like the examples I'll talk about are literally changing text files, which is the exact same as tech. So yeah, don't worry. So one question in the room, because it wouldn't have been picked up there. Just to confirm, we won't just be talking about software development today. I tend to say it quite a lot as it motivates quite a few things. This can be used for lots of things, and as one of the examples there was, if you're wanting to maintain kind of LaTeX and developing LaTeX code, any kind of notes you have, even if it's documents, Markdown, then this is applicable too. And the examples we'll go through will cover that. Yeah, on the ODL program, most of our courses use GitHub to kind of update and change their notes as well. So we're using it a lot for that. We use R Markdown, which is just a kind of rich text editor, but allows you to embed R code within it as well. So yeah. Hi. Sorry, can you speak up slightly? I'm sorry, I can't hear. MATLAB, yep, any language. Yeah, yeah.
So if it can't really deal with this, like images and stuff that well, but it can't track changes in images. It can track if you upload an image or delete an image, but it can't track changes in the image. But anything that's readable in like a notepad directory is fine.
Yep. Anyone else? Perfect. All good. So I'll actually get on to the, I guess, the technical side of how we use GitHub now and what we can do. So we have the place basically where we want to store our work, we call a repository, and that's almost all the time shortened to repo. So this is basically, think of this as the home where your work is. This is like your main folder, almost, where, say, your code is, any kind of your notes are, whatever it may be. And there's two main workflows for creating a repository and linking it to GitHub. One of them is to create a repository on your own device and then just push that up to GitHub. I'll tell you about what push means soon. So that's probably the simplest way. So you just make the local file or folder on your own device, and then we just send that up to GitHub to store it. Though the other way is we can create a repository on GitHub itself, and then you can clone that back to your local device. So that will just take a copy of that, and then they sync with one another. So I'll start by talking through the first option, because the second option is quite appealing for when we want to obtain other people's projects as well. And Vinny will talk a bit about kind of looking at how to kind of copy over other people's projects. So yeah, the four main things we'll talk about is how to create a repo, how to create a file within your repo, then stage it, then committing the file, and then publishing the repo on GitHub. Quite a few words there like stage and commit. Might go, what on earth's that? Hopefully I'll clarify that shortly. So this is GitHub Desktop. Whenever you open it, this is what you'll see. And I'll give you this nice, let's get started with all these different options in here. So if we want to create a local repository on our own device, the first place we're going to go is create a new repository on your hard drive. So we just click that option there, and that'll begin the process of setting this up. One thing to add, and I'll keep kind of coming back to this, at this point, nothing's been committed to Git. Nothing's really happened, or GitHub in that sense. We've just made a folder. So now what we're going to do is we're going to make a file. So here we've made a nice poem by A. Mill. But this could be code, it could be tech, it could be markdown, it could be whatever. But in this case, let's just say it's a text file that we've wrote a poem on. So we're going to create this file and we're going to add that into our repo. Again, we've not committed anything, we've just added a file. So nothing's really happened in Git or GitHub at the moment. Now we go back to GitHub Desktop and we'll see the following. So we're now able to see some changes, and this shows up here. And we've got these three different points, which I'll talk through. So the first point here, this is called your branch. We're going to talk more about branching soon, so don't worry about that for now. This tells you on the main branch, which is basically the main part where everything's stored. The second point here is your history. So this is a history tab. And once you've made a few kind of commits, or you've kind of added new files and updated this history will show you all the different changes you've made. So it gives you a nice timeline of everything that's happened within the repo. Right now, there's none because we've not done anything. And our third tab here, so this is changes. So this is what's happened in here since the last time something happened, which obviously the only thing we've done is nothing. So we've now added a file. So we can see that this file's been added here. And this tick means the file's been staged, which means it's ready to be committed, or basically the change is ready to be approved. You can also see here it gives us detail in the file. And we can see all this green highlighted here, which means this is brand new. This is new changes. We'll go through some other examples later where we're updating files and you'll see, or we're updating things in files and you'll see the different areas highlighted where those changes are made. So now we've made that change. Now we're like, I'm happy with this. I want to, yep. Yeah. No, so yeah, so this is basically, think of this as like, it's just providing like a view of your files and what's changed. You can't really, well, you shouldn't really edit code in here. I don't think, yeah, this is basically just showing what's changed. So if you use, say, using RStudio or using like Visual Basic or something, you can edit in there. And then this is just basically saying what files have changed and what's changed in the files at that point, yeah. So we don't use this as a code editor.
So once you save your notepad file and save it in the folder that's linked to all that linked in this, you'll see the changes up here. So this is just indicating that we've added a file into this separate folder. And so there's no kind of editing or anything here. It's just showing the differences between what we had and what we have now.
No, I sort of get the, sorry, I'm going to go down. I was just trying to like, gel it, make it gel with like how I think, I have folders on my desktop, I have stuff there, but now I kind of like put everything in sort of GitHub folders, and that's where and all those would talk to this.
So it would look the same, right? So the folder on your desktop would just look identical. It's the record of it online. So this is basically difference. This is basically saying that our record online is missing all this stuff, and we've added in our folder, which just looks exactly the same as a normal folder. We've added all this stuff, and but crucially, the difference currently between the online and the on your computer version.
Right. Oh, so yeah, so we've seen these changes. Now we're happy with it. We're like, yeah, I'm happy with this document. I want to add this to my folder. So now we want to commit this file. And you can think of this almost as creating a version of the files, or like a kind of snapshot of where it is at this moment in time. So it's like a timestamp that's kind of been added in. So say now at 3:30 on Friday, I basically added this whole text file. So you can think of it just a kind of snapshot in time. This is what changed at this point. And so here, before we commit, just make sure everything to add is ticked. So automatically, when you go on GitHub desktop, everything changed will be ticked. Everything is there. Certain things are removed, but we'll talk about that later. And this is just saying it's staged. So just make sure that's staged. And later on, we'll see we'll have multiple things here. Then we have this part down here, and so we added it. This is basically just describing what this is. So you can say something like, you always get an auto-generated one, which is usually create whatever the file is called. It's created this text file called code, and you can add that in there. And we'll talk a bit about meaningful messages. I will talk from experience because some of mine are just meaningless, so you shouldn't follow my example. And we can have a description here as well, which provides a bit more context. So this can be more useful if you're adding a lot of changes at once, for example. So once you're basically happy and everything's ready to go, we press this blue button down here, commit to game. And that will commit this, and we'll create a new version of your files. And we'll basically update this, confirming the changes that we made. Basically adding the text file. So a quick aside, because we will do some slightly messy things in our we're going to use these visualizations called Git graphs, and they basically visualize all the changes for all those different about end times, all those different commits we have. So this will help you talk about branching. So it's not very helpful now. This is what we have. So you can see all we've done is one thing. We've just added or created that whole file. That's the only thing we've done. So it doesn't look very exciting now. It will become more useful later. I just wanted to introduce it. Because I like looking at things like this, which just looks a bit like a nightmare. But this is basically your branching shortly. And this can be really helpful for when you've got lots of different things. Things in this visualization of it. So we've connected it. And once this is updated, you'll see we've got no changes anymore. So there's no local changes. So that's been approved, nothing's been message, everything is pretty much fine, nothing's really happened at this point on GitHub desktop. And we can go back and look at our history, and let's get back to that message we created there. So it sits in our history tab. But the one thing is, using Git, we've used Git successfully on our own device. We've still not published this in GitHub yet, so that's still yet to happen. So that's the next step we have to do. And if you think of GitHub, this is kind of where we online, and it always looks so including. I think maybe not so useful way. I think they're a bit like driving. You can imagine it like that. So we're now actually going to push this to GitHub so it lives online on our repository online attached to our account. So we can publish this repository text up. So you see up here in the top right hand side, we have this publish repository button. So we just click here to start this process in this one thing. Obviously, this example is fine, but just make sure you're allowed to share everything in your repo. So we'll talk about public and private repos shortly. But just make sure that what you're submitting doesn't contain sensitive information and you're going to actually do it. This is what will display up here once you've done this. So we're told to publish a repository. Our repository name. We just call this tutorial 1 because it's a tutorial within the course notes. Also getting a meaningful, suitable name for what you're doing. Project, it's the notes to the course, the name of the course there as well. And we can choose to make a repository private or public. And you can probably guess what that means. If it's public, anyone can you can just access it. That means it's publicly available. So this is ideal for things if you package or if you've made some kind of online course which you can host on GitHub and you want to share it, you can make it public. If you're working in something that's either say in development or you just want a few collaborators on it, you can make it repository. You will immediately have access to it and you can control who has access to it as well. So the one thing is to say, well, if you start your repository private, you can public and vice versa, I believe. Yeah. So you are able to change back and forward between them. It's just the situation obviously changes. So once you've decided on that, you can then just press publish. And this will then publish your. And if you go to GitHub at this point, you will see your repository there. It's being published on GitHub. And you'll see a page similar to this. And you can see on that page we have the code file that we added. We've also got a repository name up there as well. A lot of other things that we'll touch on shortly, but nothing major to worry about. So you can see that's online area, and you can download that somewhere else on another device, for example. So now talk a bit about updating. So that was how we publish it. Then suppose we want to make a change. So from the perspective of Git, updating, it's the same process I just described. But if you're not kind of from a computer background, it may be a little bit different. So let's say we're going to make that code file we had. So instead of making it a text file, we're now going to make it a markdown file. So we're just changing the file type of it. So let's say we do that. And from the perspective of Git, this is basically the equivalent of deleting the text file and then creating a new file. So that's how Git interprets this. And if you look here, you can see we've got plus and this red minus beside these 2 points. So basically, you can see we've added the markdown file, which is that's in green. So Git sees, oh, there's a new file. It's acknowledged that. And we also see in the red that includes the text file as well. So it thinks it's been deleted. And the green here is just showing all the stuff we're adding to the file. And if you click on the form.txt, this will also that has been deleted at that point. So the exact same way we did it before, and our Git graph would look like this. So remember, first time we made the form in the text file, then we connected again, and we've renamed it to that second change. But again, that's only connected to Git locally right now. So there's GitHub at the moment. So it's only changed in our device. And that's only place we've registered it. So on GitHub, we still just have this little thing with file. So we'll talk about how we update GitHub just shortly as well. But before we do that, we'll add a title to this markdown file as well. So with the markdown file, we add a title. And that will add a section title to it. So what we've done is taken that file we had, just add a title. And this time we will see the changes reflected in the markdown file because we committed that last change to the text file, and then we can see what's being edited in our markdown file. And you can see where the kind of changes in code will come a bit more, or changes in kind of files will come more apparent when they're updating things. So you can see that the previous line, which didn't have this as a title, is saying that's deleted. And green, we've highlighted that we've added this title with this hash symbol here. So we can see the change reflected. And then basically we can just give this a commit message and then commit again. So you can see down here, there. We've just added a markdown header to that, and then we can commit that change once more. So again, everything's been local here at this point. We've not went to GitHub yet. So our local Git graph will have the following in it. So we made our poem in text, we then made it a markdown file, and then we added a header to this. But the GitHub Git graph's the exact same because we've not pushed anything up to GitHub. Yes? Yep. Is that better? Not a good technical day, is it? So let's fix this now. So basically, we want to synchronize what's happening locally on our machine. So we've made those changes, and we want to sync that with what's online in GitHub. Is that better? So to do this, we have to push these changes. So we basically have to take the changes we've made locally and push them up to GitHub. So to do that, we will click this push origin button up in the top right. So we just press that button there, which will then push this. And if we go back in GitHub, you will see that the changes have been highlighted. So we see this in Markdown, and we've got that last commit message beside it, adding the header syntax as well. And that shows the changes below. And we can see up here in this number 3, this basically shows how many commits we've done. Because you remember we did 2 commits before we pushed it to GitHub. GitHub won't skip if you did like 5 commits locally, and it wouldn't be out of sync with what you've done locally. It keeps this in memory, and it'll store all those commits that you've made. And that's our updated file there. And we also see, as I said, the commit message we had from the last time, which is a good reflection of kind of when files have changed, because they'll be tied up with the commit message. So it kind of gives you an indication of when the last thing was changed to this particular file. There are some special conventions that I should add. We'll talk briefly about a couple of these in a second. So one is git ignore. So this is a list of files that, say you have a repository or your folder with all your files in it. Say there's some files you don't want published to GitHub. So it could be things that contain, there could be, I don't know, like stored like R memory files. Could be maybe sensitive information you might have in there, and you just don't want that published online. You can specify this within the git ignore file, and it means it will never be committed to your repository. You can actually edit this in GitHub Desktop. It's a bit clunky, but if you go to repository settings and under repository, you can edit this in there. You have to use git commands to edit this. It's a bit, well, it's not nice, but you can do it if you want to. Another thing to talk about is a README. So the README, you could imagine, is effectively the homepage of your repository. So it's the first thing that people will see when they go on it. This basically should provide information about what this repository is. Particularly useful, again, if you have things like software packages, you can provide lots of installation information, reference a lot of files, for example. Imagine it like your homepage. And also a license, and this is more important for when you're sharing things. So when your code's being shared, as I said, packages is a good example here. It basically tells people how they're allowed to use your files. Though I would add, people don't always follow it though, and I'll include myself in that. But that's because I've not really had the need to specify them, but we do have some information on licenses within the notes. I will now pass over to Vinny for the second half.
Let me know if that's okay online, please. So yeah, I'm going to talk about kind of more the branching kind of aspects, and so using other people's courses and also kind of more complex development for your kind of own projects. So just as I can see Rob there, I talked to Rob about this, about if you've say got a postdoc working on a project and you're working on a project, how do you kind of develop the code simultaneously without basically causing conflicts and having final underscore version 2, final underscore version 3, etc. type things. Similarly, if you're writing a paper with someone, you could do the same thing, right? If you wanted to edit one section, your collaborator wanted to edit another section, you could do that separately, then combine at a later date. So the first thing, this is, I guess, more of a codey thing. So apologies to Mark. So it's about using open source projects. So this would be the idea of using someone else's code and then running it within your own kind of environment. And you can also edit that code, but without affecting the actual original person's code. So this is where the kind of the README and the license is really important that Craig just mentioned. So the README should tell you how to download it, and the license will tell you what you're allowed to do with it. So for instance, some licenses will tell you you can use my code, but you can't go and stick it on your own repo. Some will say, do what the hell you like with it. It's worth having a read. They're usually relatively clear. Generally, it's not too much of a problem. So this is just an example from some big project that Dave pointed out. So you can kind of see this is kind of, it's telling you lots of information. There's additional features here that we won't go into. There's kind of doing various kind of checking and that kind of thing. And it's also telling you kind of what type of files are in this repo. And so the license will tell you what you can and can't do. So the other kind of interesting thing is for kind of open source projects, you can do this with your own, is there's this thing called issues. So essentially, if you're using someone's code and you find that there's a problem with the code, what you can do is you can report an issue. So you can go on and create an issue, add the problem you've had, and the person whose repo it is can have a look at your issue. They can have a conversation with you. They can reply and potentially either tell you you're wrong, or you can help them update their code. So there are various things, just the extra checks that's probably a bit beyond most of us, to be honest. But there's checks like this little tick that can basically check that when people commit stuff to your repo, that it's done correctly. So for instance, for this course, our repo has a spell checker. So every time Vinny messes up the spelling, it gives him a nice red cross and tells him to go try again. So downloading a project. So for instance, things like, I don't know, say TensorFlow, one of the big kind of machine learning packages, or this is kind of Facebook React. You can just sort of essentially download someone's code and kind of have it within your own system where you can edit. So this is where this kind of code button comes in, and you can download the project from there. So there's essentially three ways of getting the code. The first one is to literally download it. So that's like get a zip file, kind of download it. So that sounds nice initially, but the problem there is when you download that file like that, you completely unlink it from the original thing. So say Craig makes a change to Facebook React, and I've downloaded it. I don't know anything about that change. I can't integrate Craig's change into what I've got. And basically, eventually I'm going to lose contact with the repo. So it sounds nice, but it's not necessarily a great thing to do. So what you can do instead is you can clone it. So what you're essentially doing here is you're creating a local version of that folder on your computer, but it still has all the kind of Gitty information. So it's stored in a .git file, I think it is. It still has that information that basically links the commits from the online version to the one you have. So say when Craig then makes his changes, essentially Git has a map of how to get from my version to Craig's version. So then they're essentially still linked, and we kind of don't lose connection to the thing that we're interested in. So this is kind of what I probably recommend. So to do this, you need the URL of the project and a location you want to put the folder in. So you should be able to see that there. So essentially, again, we're just literally creating a folder on, I think where's Dave done this, in his work folder. You're basically creating a folder for React, and that's going to have all this Facebook code nicely sat there once you've completed this process. So as I said, if someone makes an update, then all you need to do is resynchronize your local repository with the GitHub version. And if you are using something like one of these kind of packages that's changing quite regularly, this is something you might want to do. Similarly, kind of, if someone has updated their course notes, you could go download the updated version when you need it. So there is the third option. This is called forking. So you can clone your own projects. So if you wanted, you can clone lots of projects that are open, but not all repos will allow you to clone it, because essentially they don't want Vinny contributing to Facebook's React thing, because Vinny can't code very well, and they're obviously paid millions of pounds to do it. So they don't want me messing with their code. Same with things like TensorFlow. What you can do instead is you can fork them. So forking essentially allows you to create a copy of the repo on your own GitHub page that's still linked,
But but it's not essentially the same repo, but they are linked. And what that means is you can edit your forked version where you couldn't edit the original version. The thing though is that you still have the metadata, so we still have that map that tells you how my forked version links back to the original. So if I want to join them back together, so say Facebook allows me to, add a cat picture to their front page, I would still be able to do that in the kind of Git environment without basically just redoing my changes on the other folder. So if, say, I wanted to make a change to React, this Facebook page that Dave said, this would be called a pull request. So what essentially I do is I want to add my picture of the kitten onto the front page, which they for some reason decided to allow me to do. And in order to do that, I need to make a pull request that's like called add cat to page or something, right? And they're going to be very happy that they've got a cat on the front page. So to do that, we have to go through these following steps. So we have to fork the repo that we're interested in changing. We then clone our own forked repo from our GitHub onto our computer. We add the cat picture, we make the changes. We do what Craig's just described. We kind of stage it, we commit it, we push it. So we've now updated our GitHub repo. So our kind of copy of the original repo. And then we create a pull request. So what we're then basically asking is we're asking Facebook, this other GitHub page, can I merge my cat picture into your thing? And what would then happen is Facebook would review it. And if they were drunk, they would go, yes, that looks great. I'd love to have a cat picture on my front page. And they would merge the documents in. More likely, they'd obviously tell me to get lost. But this kind of the process. This kind of the nice thing about the process is that say someone makes a nice change, you can integrate it. They make a bad change, you can tell them try again. You've not made a suitable change, and they can go off and they can make a better version of what they're trying to do. So once we've identified the repo I want to work with, we can click this nice fork button at the top. You should see the little purple arrow. And you can give it a new name. So we're going to call it our copy of tutorial, assume it's our copy of tutorial 1. We're going to call it tutorial 2. This is going to be our copy of the original tutorial. Yeah. Mm-hmm. Yes.
Right, so you have to like that.
So to do all the fancy blocking people, cloning your open stuff, you would have to mess with settings I couldn't tell you where they were. So if you wanted to do that, the best thing to do would be to message Dave, basically, or Google it. But it's not something we would generally do as like our kind of stuff so much. I mean, unless you think someone's going to start trying to hack your repo and do stuff to it, basically. I'm not sure what the standard permissions are. I don't know whether someone can. I think you have to be a collaborator, invited to collaborate in order to be able to commit to someone's repo. But someone could say, you could, for instance, put a pull request in on one of my random repos. And because I've not clicked some setting to block that, you could spam it with 1,000 add cat photos to my repo, and that'd be very annoying. And then I'd work out how to block it. But as a general rule, we don't really have that problem because no one's trying to do that. And you invite the collaborators you want to. You'd invite Richard, me, whoever you wanted to do, and then they'd be able to commit. And they could, I mean, essentially you want to trust the people you're inviting as collaborators because they can do things that are nasty, I guess, to your repo still, which is the very end of this talk. There's a little bit about things you can do if you want, but we don't recommend. But I guess you want to be careful who you add, I guess. This is the whole kind of point of the fork, is that someone that you don't know can go off and do this editing, and then they basically request to implement the changes. So basically requesting, you can review it, you can look, have they uploaded a virus into my GitHub profile? No, they've not. Oh, their changes look sensible. Oh, that's useful. Okay, I'll merge it. Or no, they're trying to hack my account. I'll block them, right? So that's kind of this point of this kind of forking and then pull requesting back into these original account. Okay, sorry. So we're going to give it a new name and a new description. So this is us creating our fork of this original repo. So this one's called tutorial 2. You can now look at your repo and you can see where it's forked from. So you see where these arrows hit these arrows, and this bit here, it says, look, that Dave's personal account has created tutorial 2 that's forked from Dave's work account, tutorial 2. So actually, sorry, that's the same name in this case, but it can be different names. But crucially, look, there's still, this information tells you they're still linked. They're still connected. There's still this map between Davey Star tutorial 2 and Dave Glasgow tutorial 2, right? They're still linked together in some capacity. But Dave's work tutorial 2 is not affected by Dave's home tutorial 2 changes he makes. So we then do exactly the same process that we did before. We clone our copied, our sort of our link, our forked repo, and we can make our changes. So I don't know what I've done here. Looks like we've updated the text in some format. And then we can push and commit and do what we'd normally do back on this forked version. Oh, sorry, this is what we're doing. So then what we want to do is we want to create our pull request or our forked pull request. I want to request basically to have our changes that we've made on our forked repo back into the original repo. So basically, if we want to add our cat photos, we want to change our text, this is us basically requesting to put that back into the original repo. So the traditional way, kind of statsy version here would be a bug fix, right? If you found a bug in someone's code, you would do it in your forked repo, make the changes, pull request it back in, and they'd go, oh yes, you've corrected my mean function that's completely wrong, thank you, and I'll implement the change. So again, I guess if you had notes online and someone found a mistake, they could fork your repo, correct your mistake, and then they would pull request going, Mark can't do maths very well, and pull request it back into your original repo, and you go, oh yes, I've made a underscore mistake there, right? So that'd be kind of the logic of kind of how you would use this. So to do this, we navigate to the original project repo. We click on the pull request tab, and we click on the new pull request button on the right-hand side. Where have we gone? So we then click this button that says compare across cross forks. So remember where Craig had the kind of green bits and the red bits that showed the differences. Here we're doing exactly the same thing, and we're comparing across the two repos. And then you want to select your repository. So this is your forked repository you want to select. And then you'll see your commit messages, and you'll see the content of your commit. So you see the changes that we made earlier. And now in this green bit down here, we changed the README to change it from this to this kind of updated text. And then you can rename your pull request and then create your pull request. So we've basically seen the differences we've made on the last slide when we've started to create this pull request. We can see the differences we've made. We've then officially started creating this pull request, giving it a name so Christina, say, knows what it is I'm trying to do to her repository. And then we're creating this repository, which Christina will then see on her own repo. It's now down to Christina, or the original owner, to basically review what I've done and decide whether they want to merge it into their repo, or quite often in sort of a more advanced kind of repo, you might get a discussion as to whether your code changes make sense, whether your code is high enough quality to go back into whatever the original repo was. So if I've done some, fudged code, and their code is all pristine, they're not going to let me put in my fudge code. They're going to tell me, go clean your code up, then try again. You can have this discussion as part of this, on this basically pull request page. So basically you can have a conversation. I think it's, here. Oh yeah, look, somewhere down there. You can basically add comments and stuff and have a conversation between me and Christina as to whether we're agreeing to implement my changes. So it's just a cartoon. So I say this warning and then I don't do it myself. When someone does try and push something in, join a branch together, you really should review the code and not just assume someone else has done it. Otherwise, you're just going to push in some absolute rubbish at some point and you're going to regret your decision. So basically, have a look at the changes, which are all going to be nicely listed within this pull request, and you're going to be able to see the differences, check they all make sense before pressing I agree to merge this back together. So the one thing I think just to say is, if you are doing a kind of pull request, you can do this on your own project as well. So for instance, if you have version 1 of your notes, version 1 of your code, and you decide, I want to create a branch, which I'll come to in a second, make an update, I add a new section, add a new function, you might want to do that separately and then pull request it back into your own project. You can essentially review what you've done, look at all the changes, and at no point does the code in your main branch stop working because you've done all your changes in a separate branch and then you've checked it when you've merged it back in. So similarly, when we've kind of been doing this, if me and Craig are working together, Craig might create a branch, pull request, and ask me to check it, despite it being kind of our repo together. No, they're not quite the same, but you end up with multiple separate versions and essentially doing the same thing. But I think I'm getting to that next. So sorry about that. It's just there's 2 versions of pull request, one from a fork and one from a branch. But essentially, it's joining 2 versions together. I probably should put this slide somewhere else, to be perfectly honest. Commit messages, again, try to say something useful in your commit messages. So when you want to see what you've done, or say Rob's postdocs made a change here, and Rob wants to know what they've done, Rob doesn't just see blah, blah, blah as the commit message, because the postdoc's really good and they've gone, added solar model 512 to this repo. Rob goes, oh, yes, I know what that means. And we're kind of good to go, right? As opposed to blah, 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 where he has to go look at the code, try and figure out what they've done. If he's looking for where they added some model, he has to go through every single commit that's like blah 1, blah 2, blah 3, and try and find the one that's actually useful, right? So if you actually put a nice commit message in, essentially it's saving you, or you when you're trying to find version 3.2 time, or Rob when he's trying to find where this model gets added, you're saving yourself a lot of time and kind of pain basically doing this, and it takes you milliseconds extra. So yeah, basically don't do this. Just gobbledygook, right? So traditionally, there is technically a nice way of doing it. Which I think it's if applied, this comment will, and then whatever the message is. Realistically, just write something vaguely informative. No one cares. But this is the official advice if you want official advice. The one actual bit of advice I would say is commit regularly. The more you can commit, the better. Computer scientists will tell you every 30 seconds. Statistician might say every week, every day, right? Basically, all I ask is try not to do it like once a month. Try it if you make something that works and something that's nice, commit it there and then. Don't just wait, because you might mess it up between it working and it not working. So if you commit it once it works or it's nearly working, it's better to do it then rather than forget to commit it, break it, and then not be able to go back to it.
Imagine I do something, I commit it, I think, yeah. And then like afterwards I come up with another idea of doing something and I decide what I've done is wrong and I want to kind of go back. 7 steps, scrap that.
Yeah.
I think that's a silly idea.
So you could do that, yeah, so exactly. So if I was to write a function, commit it, break a function, commit it, I can then decide, oh, I hate myself, I'll go back to the previous one. That's possible. We don't recommend doing it like that because you can get yourself in trouble. It's easier to fix it with a copy and paste type job, but you can go back to the old version, right? Copy it out of that old version and then recommit it, your updated version. We recommend doing that to avoid getting into basically editing history kind of Terminator style.
What you just described, I did when we made this one. We'll talk about it.
So
you can do it, but it's kind of treated with extreme caution.
So as you can imagine, Dave and Andrew are very pro doing this. Me especially is hell no. Craig is more agreeable and actually did it. I've never done it. I'm just like, do not do this. It's basically like Terminator films. Don't do it, basically. So, there's differences of opinion, and obviously there's a reason why Dave and Andrew are happy doing it. They're much more capable in terms of coding and programming than myself and Craig, right? That's why they're happy doing it. And it's why we recommend you don't do it on the assumption if you've come to this course, you're probably not super amazing at everything, right? You're not, not from a computer science background. So the other nice thing you can do, so say you've done a month's worth of code and you decide you want to split it up into different bits, you can actually just commit different sections. So we could try and just commit that, just commit that, and just commit that. But imagine from a coding or kind of paper perspective, you might be talking about a function, 2 different functions, or you might be talking about 2 different sections of your paper. And what that allows us to do is basically say, I edited this function and commit it, and then go, I edited this other function and commit it. And therefore, when Rob's looking for when this function changed, it's a lot easier for him to go and find his commit message and see where it is that he's made the change. So we can see we've got different hunks, and we can see at the very top, we've actually selected these ones here. So they're going to create a nice commit message, and we're basically going to say we're going to capitalize the 6 in the poem title. So we're only committing this change at the very top. So the red one and the green one are linked here because one is replacing the other. But crucially, we're not committing these bottom ones. So we're going to do exactly the same with the other 2, and we can make separate commits with a different commit message saying, I don't know what we've done. We've capitalized 6 in this line, and we've done it here as well. And we basically have separate commits for each one. That basically allows us to track better what we've done. So you don't necessarily have to do this, but I would say if you've got kind of 2 big chunks that are separate, you haven't committed them already, it might be nice to do them one and then the other.
So this, when you branch, put that together to do
No, so this is just one single branch. You've made 3 changes, the 3 or 2 at this point, but you want to commit them separately in 3 different bits. So essentially to allow you to give them a different name.
I got these. I see a screen like this, but I couldn't see how to decide whether or not to.
So you should be able to basically drag along the numbers and highlight.
Okay, what I highlight.
Highlight the thing that you want to commit. So you can similarly, if you'd made changes to 2 files, you could untick one file and not tick the other file. That's obviously that is easier, yeah. But yeah, you should be able to just highlight it. If that's something it doesn't say in the notes. If you read the notes and it doesn't say that, then is that the case? Okay. Okay, yeah, okay. Yeah. I was gonna say, if you do have a look and it doesn't say it, then just let us know and we'll fix that eventually. So now we're on to the most exciting / more difficult part, which is the branching. Now you can obviously, this is your kind of solution for having multiple users, although again, you can do it by yourself if you want. But essentially it's making different versions within the same repository. So different to forking, these different branches are all in the same repository, whereas forking was split into 2 repositories. So you could have branches in 2 copies, right? So I'm not going to tell you this any longer how to actually do this, but it's all in the notes. Instead, I'm going to try and give you the idea of why you might do this, how it might be useful, and basically what the point is. So there's lots of different approaches to branching, depending on how keen you are, depends on exactly what you want to do, and depending on how many people you're working with, depends on what you want to do. Just do what makes sense. We've tried to give a few kind of more advanced examples of how to do it. I think they're a nice way of doing it if you're working in a group project, but they're not really necessary if you're doing it just by yourself. So when you first start out, most people will just do this. They'll do an initial commit, change, change, change. You've got your one single branch. No one cares, it's just you using it. You're not really trying to publish it very hard. You're not trying to have users that are using version 3, for instance. You're just trying to keep an updated record of how you change things. The more advanced strategy, which you can use still by yourself, is that every time you want to add a new feature, you create a new branch, you do all your changes, and then you pull requests back in. In this scenario, the only changes you make to your main branch, which is this blue one, are the pull requests of your features back into your main branch. So you don't edit your main branch at all. The nice way of this is you've always got a working version, a working version, a working version, But whatever you are on here, you still have a working version that's available to you to still use. So, you know, if you're a big project, you might label this version 3.1.1, 3.1.2, you know, that kind of thing.
Sorry, that question, why are some green instead of red?
Because they're different branches, basically. So it's basically labeled to, you're creating a new branch here called feature, you're doing changes, and then you're basically remerging feature, and you're then going to delete this feature branch. You then create this new branch called bug fix, do the same thing, and delete it back in.
Branch.
Yes. So again, you can do, official advice here is from us at least, you can disagree on the internet, is to always branch off the main. So there's kind of reasons for that, is to try and it stops it getting overly complicated. It does cause other issues, but it stops it getting completely mad. There are ways of basically combining branches in other directions, which is we'll come to in a bit, that kind of might help with some of this stuff. But generally, we advise don't try and branch off these features, and kind of everything gets a bit out of hand. If me and Craig both branch from here, so I would have branch called Vinny branch, Craig would have branch called Craig branch, everything's grand. Yes, so if Craig makes a change, I make a change, and we try and merge them together, there'll be problems. Yes, I'll come to it. But yeah, you're seeing the problems in advance, right? So, okay, so I've just literally described this. So when we were making this course, basically this is what we kind of did, and it basically allowed us to add features without getting each other's way. So, you know, I've drafted Unit 2, and I asked Craig to review it. Craig's busy. I still want to carry on working because I've got, you know, that half an hour free time that we love to have. So I then open another branch from Unit 3. So again, I might do it from where I opened Unit 2 because there's no merges to the main. Craig merges Unit 2 back in because he's happy with it. And I can, what's that then? Oh, sorry, I would usually be the one that merges Unit 2 back once Craig has reviewed it. And then the draft of Unit 3 is still separate from Unit 2. It's not getting merged in as well because it's on a separate branch that I've created specifically for Unit 3. That's probably a slightly complicated example. I thought it made more sense another time. So let's start with a relatively simple example. We have our markdown file with our very exciting hello message. And we have our following Git graph where we've just added our markdown file. We decided the next thing we want to do is we need to excitingly add an exclamation mark to our hello to make it so much more, you know, reader friendly and exciting to read. So what we're going to do is we're going to go to the main menu. We're going to select branch and create a new branch in order to make our new feature. Our new feature here being this exclamation mark. Totally overkill, but let's just go with it. But imagine if you're adding kind of a new model, a new section of your thing, this is what you might do. Here, our new feature is an exclamation mark. So it's very exciting. So as you can see here, we're going to call our branch shout because we're changing it from saying it to shouting it. And we're going to create our new branch. So we're then going to make our changes. So we're going into our branch. Sorry, we're going to our branch. We make our changes and then we commit it. So yes and no. So if I create a new branch on my computer and I don't push anything to GitHub, no, Craig can't tell that I've made a new branch. If I make a new branch, I think I'll have to make a commit as well and then push it to GitHub. Craig will be able to see and look at what I've done. And one of the nice things he can do is if he updates some other branch, he can actually merge my changes into that branch. So we'll come to that in a bit. But yeah, essentially, just remember there's this difference between this kind of on your computer version and this online version. Anything online, Craig can see, but you know, Craig might be 3 versions behind online and I might be up to date. Mine might be the same as online. So Craig wouldn't see the changes that I've made if he hasn't updated his version from the online version. So if he hasn't kind of resynced it. So we make our changes, we commit it, we do exactly the same. We're doing this on our branch called shout. You can see at the top middle of the screen, we're on our branch called shout. So we're not making any changes to the main branch here, we're making changes to the shout branch here. So adding this exclamation mark, you can see the changes in the red and green, and then we're committing this. So that gives us this diagram. So we've still got our main branch here, which has our hello without the exclamation mark. But we've got this second version here, which is our shout branch, where we've got hello with an exclamation mark. These are two separate versions currently. So yeah, note we have a new branch, very exciting. So now we've made our change in our exciting new feature, which is this exclamation mark. What we want to do is we want to merge it back to the main. So then the person using the main, the person using your kind of headline version of it, gets that exciting change of our exclamation mark. So what we need to do is we need to start the merge. So we click on, I think we click on merge somewhere, and then we go to choose a branch to merge into main at the very bottom. We choose our branch. So, so do we not need to navigate back to? Oh, I've missed out a crucial bit. We need to navigate, we need to switch back to main in order to do this. So once we've gone back to main, we then choose what branch we want to merge into main. So you want to be on, basically want to be on the branch where you're making the changes. So we're making the changes here on main. We're using the updated, we're trying to update main based on the changes we made in the branch. So we need to be on main to do that. So we then start the merge, as I said. We select our shout branch that we're trying to merge into our current branch. And we can rejoin that, we can rejoin them back together. And now we have this we're kind of at the stage here, we essentially have one version, which is our hello with an exclamation mark. We could go back to these various other versions, but essentially we're at this stage. And if you want, you can delete this branch if you want at that stage. So it's kind of advisable if you're following this strategy where you're continuously making branches, it's good to get rid of all of the extras. If you're only doing kind of main branch and development branch, you probably don't need to bother, if that makes sense. There you go, that's what I just said. So let's try a slightly more complex situation. In this case, we're going to change the exclamation mark to a question mark, and we're going to do that on our new branch called question. We're then, once we've done the initial change, we're then going to make a following change, and we're going to add this extra bit of text. Oh, sorry, this is so. Okay, so it's just a warning that if you try to switch back to main before committing your changes, you'll end up with some problems. So there's this thing called stashing, which I'm not going to go into, but basically, essentially, my advice would be commit the changes on whatever branch you're on before trying to switch branch. Otherwise, you'll end up with difficulties, not terminal difficulties, but problems that you probably don't want. So we kind of talked about doing this on the other one, but imagine if we'd made our initial change on question, and then we'd gone back to main, and we decided to add the second line there instead. So we've not actually added the second line here, we've just added it here instead. So essentially we've got hello question mark here, and we've got hello exclamation mark, and then the second line here, right? We've got two versions. We've not made anything that's we've not made any changes that are conflicting with each other in this case, because we've edited different lines, but we have essentially got versions that are sort of split up, if that makes sense. So we have two different, they're called heads, which is basically the tops of the head and the second head. And these have got different versions of our file. So as I said, they don't conflict with each other yet, but they are different. And they're different to the thing they started from here. This is different to this, and this is different to this. With no conflicts, the merging is still straightforward. GitHub essentially knows to take the second line from here and keep it, and it knows to take the question mark from here and keep it, and it knows that it can just do that back together. That's kind of its way of thinking, and that's what it does. And we've got back to now our complete version. We've got hello question mark, whatever the second line was, all in one nice version. So we can now again delete our question branch if we wish. So now we're kind of getting to the situation that Rob was kind of asking about earlier, is what happens if I change something and Craig changes exactly the same thing? What do we do at that point when we've got two different versions of exactly the same bit of our code, text, etc.? So let's create a new branch called capitalize, and we're going to change it to capital hello from whatever it is we had. I feel like we've lost the line here somewhere in the thing, but that must have been deliberate. We're going to then change back to main, and we're going to change it from hello to hello dot. Well, it must have been hello question mark, wasn't it? But so essentially now we've changed the same line here as we've changed here. So the two different heads, we've changed exactly the same line. Git is not clever enough to work out that the first 5 letters and the 6th dot are different. It only looks at differences between the lines. So we've got a problem now that we've basically got 2 different versions. So this is what we've got. You can see we've got hello dot and capital hello. So what the hell goes here? That's the question, right? I don't really know. No one really knows. Crucially, Git doesn't know. Git has absolutely no idea what it's meant to do here. So what it does is it goes and says, you made this problem, sort it out yourself. So it sends it back to you and says, go fix your stupidity, you've done something dumb, right? So there's a few ways of dealing with this. The first one is to just press ahead and merge it anyway. Essentially what that does is we're basically just saying we're happy to have this kind of conflict built into our code, our text. Now, if this is your code, if this is code, there's a good chance that's breaking everything, right? With the text, you're just going to get some weird print statements, as you'll see in a sec. So GitHub's going to tell you that you've done something stupid at this point, and it's going to give you an opportunity to go and edit what you've done and basically fix what it is that's wrong. So you'll see something like this. You'll basically see the one version here and the second version here, and all this is going to be in your text file. So you're literally going to see in your text file, if you open it in Notepad, all these arrows and heads, all these equal signs, all these arrows. So essentially your nice title has gone from hello to 5 lines of merge conflict, right? So this is why it tells you to do it straight away. So you can actually deal with it and kind of make it so that the version you're actually going to commit is going to be nice and all clean and what you actually want to do. And you have to fix this manually to do this. You can't just, there's no way of going, I choose that one. You literally have to go in and delete, capitalize, whatever it is you want it to do to basically fix that problem. So we've decided we're going to do this with the thing we're actually trying to do, which is capital hello dot, right? Which is very logical, but Git has no idea that's what we're trying to do. So there's a better way of doing this. So we've essentially done the same thing. We've ended up with goodbye on the right-hand side, and we've ended up with hello on the left-hand side. I think we've lost the dot, I think is the crucial difference between this one and this one. But essentially we've got 2 differences again. So if we want to avoid the horrible situation of having this kind of clump of merge conflict in our main branch, what you instead want to do is basically have this problem in your side branch instead. So it's away from your nice release code, your pretty version that you're showing to the outside people. Instead, it's in your kind of development branch or goodbye branch, which we don't really care whether, we do care it's working, obviously, but we kind of less caring than the main branch. Oh yeah, so I think last time I gave this talk, it was for another series group. I had a ton of software engineers. I was like, don't piss off the software engineers. Do this instead of what I just showed you before. And I like the dogs. So to deal with this, so as I said, let's avoid dealing with the merge conflict on main, instead fix it on goodbye. So the way we're going to do this is by merging from our main branch, but into goodbye. So instead of merging from goodbye into main, we're actually doing the opposite direction. So we're basically causing the merge conflict in goodbye rather than the merge conflict in main, if that makes sense. So the way we do that is we need to switch to goodbye and then merge, select the main branch, and merge that into goodbye. So in terms of our, oh yeah, so that causes our exactly the same thing, our nice horrible merge conflict, but this time it's in goodbye. It's not in our kind of pristine main version that we're obsessed with keeping nice and pretty. So we can fix it and merge and make the merge in goodbye. So I think this is a song of some form, someone told me. Beatles song, apparently. Not my area of expertise. So what you see here then is we see how we've merged into goodbye. And you'll see that goodbye is in the head of goodbye, the end of goodbye is in front of main. So this can be very, very, very useful. So as I said, if I'm working on a really complex new feature in my branch called feature, Craig makes an update on main. So say Craig fixes a bug on main. Oh, that's literally what it says. That bug fix is going to be useful for me as well on feature, right? So say Craig's fixed a function and I'm developing elsewhere on this other branch. It's going to be useful for me to have this change that Craig's made into my new branch. So this would be the general kind of coding purpose of why you'd want to do this. Basically, if someone makes a change, or Craig could add a feature on main, right? He could add a new feature and I'm like, oh, I want to use that in my new branch, right? So therefore, what I would do is I would merge Craig's bug fix from main into my feature. So at this point, all my development code is still sat on feature, but I've managed to have the niceties of all Craig's new fancy code is now ported into my branch as well. And therefore, I can continue developing my feature with Craig's bug fixed function. So I don't end up with a situation down the line where I make it work for the broken function, and then I find out that 2 months ago, Craig fixed that, and it's completely different now, and he completely reorganized it, and everything I did for the last month is now essentially based off old code and doesn't work anymore. So now we no longer have this conflict. What we can do is we can switch back to main and merge back our changes. And now we've got on our fancy shiny main branch, we've now got exactly the line from the Beatles that we wanted, right? Uh-huh. Uh-huh.
Qualifies them to sort of supersede you in the sense of, okay, maybe they've changed the problem, and you're the one who's doing the right thing.
So usually, so in a development-y sense, so sorry, the question was, who takes precedence, basically, someone editing on main or someone editing on goodbye. So generally, the rules that we would use is you only merge into main if we're all happy that that's completely fixed. So main, therefore, takes precedence because main is considered to be correct and checked. So it's been reviewed by someone else or me even. So Craig might, for instance, make a change on main, ask me to review it. I go, yes, I agree. It's then on main. So that then obviously takes precedence over my development branch separately. Because my development branch has not been checked by anybody. It's just my development code. That makes sense? In the way that we're coding it, in this kind of strategy, yeah, main is your kind of gold standard. Anything down the side is work in progress. And therefore, the main takes precedence over anything else. So one nice thing you can do if you start getting a bit fancy, which I don't think I'm going to go into, can't remember, is basically link all this stuff to issues. So for instance, if Christina has put an issue on my repo, I go, oh yeah, that's a problem. I create a branch, and then I make commits, and what I can do is I can link those commits to Christina's issue. So say this is Christina's issue here rather than Dave's. Every time I make a change and I tag Christina's branch, you'll see Vinny has made change 1, Vinny has made change 2, Vinny has made change 3, and Christina will see that I'm in the process somewhere of fixing it. And I can write messages to Christina if I wanted saying what I'm done, and obviously everyone else will be able to see it as well, but it might be me and Christina talking about these changes. So that's kind of slightly more complicated, not necessarily useful unless you're starting to get into a larger kind of development-y kind of thing. So if there's like 3 or 4 of you working on it, this starts to become kind of more useful. We sometimes do it, but not religiously, I would say, when we've done this project. We've sort of half done it if we remember and not done it if we don't remember, I would say. Yeah. Okay, when we're trying to finalize, we did it. When we're just kind of write something on a piece of paper, it was okay, just get over it. And you can do fancy like tick boxy kind of to-do lists as well, which Dave liked. So yes, various people have obviously lots of people think, and quite rightly so, that one of the big things about GitHub is being able to basically undo when you do something shit. And you may notice we've been talking for an hour and a half now, and I only mentioned it to say be afraid of terminators, basically. There is basically a reason for this. The reason for this is where you can cause yourself real problems. So there's kind of, we basically say anyone that's not very confident, avoid doing this and find a kind of more fudgy solution that avoids you creating horrible things in your code that can basically end up with you actually permanently deleting stuff or permanently breaking your code, which you can do with some of this stuff if you try to do it. So this is why we kind of say avoid doing it. So going back in time and looking at your code, that's one thing. Going back and trying to then switch back to it or edit it, then you're getting into the real kind of Terminator, people turning up and trying to kill each other kind of situations, right? You can go check it. So what the checkout function is we can go back to some commit and go check out that commit, and then I can use that code. So for instance, if I have version 2 and I go, oh, my other bit of code only runs on version 1, I can go to this, check out version 1, and then run my other code using the version 1 code. So that would be a sensible use case. You're not doing anything to this code. You're not messing with it. You're just using it. That would be sensible. That's perfectly, I'd advise you to do that if you need to do it. I would just caution is you could also go back and go, oh, I don't like that change. And GitHub will allow you to mess with it. And that's what we really kind of advise against. If you can really help it. Again, if you're into that situation, my recommendation is always going to be talk to Dave or Andrew, basically, or someone who's very confident with this stuff and can basically supervise you essentially and stop you doing anything stupid. Craig's done it. I've never even attempted it personally.
So in the sense that you've got a version 1, you do some new thing that you think is great, you branching, come back in, you've got some version 2, it's got some new feature, you're using it, you find there's a bug in it, where you knew that bug didn't exist in version 1. You're better off looking at version 1, finding what the error is, and branching off the version 2 and correcting it and making a version 3. So it's all like, does that make sense? Version 1 and starting with
so I'm going to just answer the question rather than try and interpret what you said, which I think made sense, but not quite to me. So what I would do is I would go back through. So you identify you're in version 2, you identify what the problem is, what's not working. What I would then do is I would go through the commit messages, find where I made the changes, try and, if you can, identify what's gone wrong, or go back as far as a version that works and try and work out basically what is it that's caused the problem. Instead of trying to branch out of that, fix it, merge, and do horrible things, what I would suggest is literally looking at the differences, copying and pasting it into a Word document or a Notepad document, and basically committing on your branch, making, say, a new branch out of version 2 and trying to fix that bug. That essentially is stopping you meddling with time by doing that. You're going back and you're looking at history, working out what's wrong, but you're not messing with history. You're just looking at it, working out what's wrong. So that would be our kind of recommended solution to kind of that. So just say for the simple sake on the previous commit, you did something wrong and you just want to undo it, like Christina was talking about earlier. What I would suggest is looking at that version, copying the function out, going back to where you were, and then recommitting that function on top of whatever, instead of whatever it is you messed up in the last commit. So instead of undoing one commit, you're basically adding a commit that undoes it. I would, just copy. I would open a new notepad or new whatever, R file, whatever, copy the two versions out, look what was wrong, conclude on a version I was happy with, make the changes in a branch so I can test it and not mess it up even further, and just try and work it out like that. So just avoid having to go back and essentially edit. So imagine if you edit a bit of history, it affects everything going forwards, right? So.
So you know how like you were talking at the beginning about like probably what I do. I'm a V1, V2 person, and so like all the bits of doing that, you can see. So if I look at my actual directory in my computer, am I seeing these old versions? Like where is
So you're
like past sort of versions of the code being installed?
So your directory is in the thing that you have checked out. So as a general rule, that's the latest thing. That's the top of the head of our branch. If you use checkout and go back in time, the thing you see in your folder is the thing you've checked out. So what is stored that allows you to go between that and the kind of this history is basically Git stores in its kind of hidden files. It stores a map of how to get from one commit to the next commit. So this is, I guess, why I'm cautioning against editing it, because if you start editing it, you start messing with this map of how you get from different places to different places, and you start causing yourself problems. But essentially what Git is storing is, instead of storing 100 versions, it's storing your current version and 99 maps of how to get back to from one to the previous, from that to the previous, from that to the previous. So say I want to go from my 100th commit to my 95th commit, I basically need to do follow the 5 map instructions to get back, and that's what Git does. So if you were to check out that kind of 95th one, essentially what you're telling Git to do is to use its map to take you back there, and it's still storing the maps so you can get back to your 100th commit, and it's still storing the maps so you can go even further back if you want. If that makes sense? Oh, you can avoid it. Okay. So you can essentially avoid these problems by small commits, by merging your main into your branches, issues, and doing things in smaller manageable features. So basically by being kind of more sensible with how you edit code, doing it in smaller chunks, doing better commit messages, making sure your branches are not getting completely disconnected, right? If you've got 2 branches and they've not talked to each other in 2 months, that's probably a bad thing, right? You've probably, me and Craig working on 2 branches separately full time for 2 months, we're going to have messed with the same function. We're going to fix the same bugs. We're going to have done it in different ways. We're going to expect features that Craig's going to expect features in his branch. I'm going to expect features in our branch. Basically, we're getting to the point where we've got a real shit show trying to get the 2 things back together. So this is what I was just talking about. Git checkout when we go back in time. What you actually get is this thing called a detached head situation, hence the Harry Potter photo. Where, I mean, it's still partially connected, right? That's going to say it kind of makes sense. But basically, if we call the head the top of where we are, we've got a detached head because we've moved down somewhere else in the thing. So we're no longer, our head's basically here rather than here. That's the logic, right? If I'm the top of the branch, the head is here. If I go back in time, I move my head to here. It's a detached head, right? Because it's now sat in my hands. It's a bit weird. There's basically more information how to fix this. It seems to happen more than you liked. I started having detached heads about 5 years ago, and it was only when trying to quiz Dave on what the hell a detached head was that I worked out what it actually was. So I have no idea how I made a detached head. I didn't do it intentionally. Me and Dave had to have a discussion as to how on earth we actually demonstrated a detached head, because we both know we'd had detached heads, but neither of us knew how we'd got there. So it does happen if you start clicking things and you double click on things that you're not meant to, stuff happens, and right. So the more dangerous things is this things like called git reset. So essentially it's allowing us to roll back changes. So this is where we're basically undoing stuff like this. And basically what that's essentially doing is it's deleting this and going back to this. So there, again, another reason why I'd caution doing this is because if we were drunk when we deleted this, we would, we'd never be able to go back and do it. We'd never be able to go back to it. Whereas if we did my kind of fudge version, we could go back and fix it, right? Oh yeah, the Git graph's not right because we forgot to do it, and it's an issue on our repo. So you can do revert, which is what Craig did, which I was very surprised at because I definitely have never touched it. But basically, this is a formal way of more formal way of undoing something. So it's undoing it by creating a new commit rather than deleting old commits. So it's a much nicer way of doing it. Probably a nicer way of doing it than reset, at least it appears to me. Andrew's probably telling me off in the chat, but but again, I'd advocate towards the fudge approach. So, but yeah, you have been warned. Basically, don't do it unless you're really confident. So that would be my thing. So thank you for listening. That's taken rather a long time. Sorry, but hopefully it's been useful. Hopefully it makes sense. The course has way more detailed instructions. If you actually want to try and do stuff, there's examples you can follow. It's really nice. So I would say have a go if you find it interesting. Can you Vinny Davies.
Yeah, no, I can send you anyone else? I guess I'll finish with, if you have questions, if you need help, please just shout.
If anything goes wrong, we'll blame you. You could slowly blame Vinny, that would be ideal.
I guess what I'm doing with this is to try and get people just to say that if you commit once a month and you've never committed before, that's a big win for us. You don't have to do all this fancy stuff. If you start doing a commit a month and in 6 months you do a commit every 2 weeks, and 5 years down the line, I will try and create a branch with them all the things on it as good ones. Then that's the list.
Yeah. I mean, this course does go from 0 to 100, and it has a lot of as I said at the beginning, that kind of case, like we have that on the little page, the user plan, like what you want to do with it. I think following that guide is much, so we covered a lot today, and it got quite technical quite quickly.
Yes, the logic would be unless you're really wanting to dive into this, would be trying to do the first 3 chapters like Craig 5 at the start. Have a go, get used to doing that. In 6 months, you decide, oh, actually, go do the next section. 6 months, you've been, overconfident, go do that being made. So, Stephen.
Yeah, so quickly, so I mean, just as a sort of rule of thumb, what scale of code and what number of people are sort of the metrics for the level of sophistication needed here? Like if it's one person.
So that's what the guy. So I think you went over the various steps. Basically, there's not really guides, some hours and some boxes. Right on this. Yeah, Mason says we're doing a single person project, do chapters 1. We're doing a green project, do 1.5. You're doing a band project, 2.1.
Advanced project is what I would say it's quite a large group.
Yeah, well, in terms of the scale of the group, but then there's also the question of the scale of the code. So now as the scale of the code grows through thresholds, you need
the more fancy your code, yes, you want to do the more advanced versions. So now with our advanced code, we've been looking at doing this kind of all this merging around stuff. When I was first starting our project, I just main branch and not
I mean, if I was creating advanced code, the number of lines of code.
I mean, for example, say you put like a PhD thesis, which is thousands of lines of like tech, but it's just me working on it. That would be a simple one branch. I don't think size in terms of files and volume of code, in terms of complexity of how many people are involved in the project, what sort of things are going on, how complex is what the code does itself. Like, I mean, is it like it's a package or something, then lots of stuff, you know?
So if you write good software, kind of like it's, you would generally split it up into lots of bits that would depend on each other. At that point, I recommend using more advanced strategy because you're not likely to change something here and break something here. If you're literally, say, writing one line lines long, I would just use one branch because it's all in one place. You can see what you edited. It's not, there's not so much interdependent. If you're writing this code the same, you've got one function calling 50 functions, they're calling other functions, etc. That's when you want to try and use more advanced scenario. That's essentially how you probably should code. Depending on how advanced your project is, depending on what you do that.
But that's the thing that worries me, like, I've got loads of different modules, like somebody breaking something and putting it.
Yeah, so that's
My version doesn't run.
yeah. So you start making the model 7, right? You can instead of done, the logic might be that you say, right, you're going to change model 7, create a branch. And then when you're ready, again, at which point, instead of you wasting a couple of hours every week checking the code, the final differences between what they're trying to push from the branch back into the main, and you spend, a solid amount of time checking that, you can test if you want it. That's the continuous integration I mentioned for half a millisecond. Basically check that you're like, one, well, this model 2, rather than model 3, etc. You can run all that as well. But what you more practically do is just check the code, check some examples that make sure everything's still that's correct.
You do that before you merge that. So
you make it follow us, but you ask it to merge.
Yeah.
You're not merging yet. That's that one where you review the code.
But I would review it by running it. So I would need to sync, I need to download.
So you would switch into the header of the branch of the post of the maze.
Yeah.
You would then run all your examples to make sure everything is working. Then you approve the merge.
And when we're touching the continuous integration stuff, like this is stuff get fancy with it, we can finish talking about unit testing. So you can't say unit tests, so there are kind of problem using cases. They have to run in pass before, even if you accept the merge before it'll actually allow it, it has to get past those tests, but that's a bit more.
Yeah, so I spelling check for our notes. Every time I put it in the pull request, it ran one. It read across to say, Vinny, you can't spell. At which point I then added 2 more commits on the language to correct my spelling. You see in the pull request, you see that. You can see Vinny made a pull request, and you can see Vinny's packages I spelled it wrong. I'll correct it. And you can see those commits in the pull request. And you can see and that updates the comparison. So when Craig's reviewing it, you see that pull request, you see that I corrected my spelling. But you can then see the changes between my current version with the correct spelling. So that's just, yeah. So that's a nice way if you have kind of code, just allowing someone to edit it without